We're making experiments on filming. My motivation for filming is not to film myself so much as filming the other guys. My guest lecturers and other people that may say something sensible that I can use next year, or that you will appreciate next year, even though Anders, sooner or later, maybe it's not available as a resource anymore. Hey, Saturday I bought this microphone at 4Sound. I had called beforehand and asked them to, whether it was in stock and whether they could set it aside for me. It turns out that when I arrived to pick it up, we have these European rules on information about people. Since they had reserved it for me and my telephone number was connected to this, they had to hide it so that nobody could find it, just in case they then saw both my telephone number and the item I bought. And they seriously couldn't find it. Huh? The specification was hide it so that nobody could find it, and when I got there to pick it up, they couldn't find it. So I got another one. That's the story. The same thing is valid now. NTNU has been promoting this filming of lectures, and then it turns out that we're not allowed because the back of your heads might be on the film, and your voices. If you cough, then your cough will be on the movie, and we're not allowed to use it. So, now, still, we assume that a video has a value that lets us kind of be a bit imprecise of these rules, but think about it. And if one of you demands that we not film, then we will just forego the filming quietly. So you should be aware of this. There may be other solutions, but we will treat this seriously. But think enough about this so that you kind of implicitly accept if you're not too afraid of having the back of your head or your cough on a film that is used by NTNU at a later stage, then I assume your consent. Okay. When it comes to the learning outcome descriptions, I don't intend to change much. When it comes to the exam format, I don't intend to change much. Be aware that in 2018 I didn't teach the course. I was on my what's called research termin. So I would rather go for references on how the course has been given before, go to 2017. Still, I may change the wording of the learning outcome descriptions. I'll talk more about that today because this has a purpose. Pedagogical thinking changes at the university at the time, and to reflect this, the words we use when we make learning outcome descriptions, you can already notice that I call it learning outcomes instead of learning goals, which is old-fashioned. So we're changing the wordings. That's one thing. The other thing is that the depth. We have knowledge and we have skills. And I have lately, the last years, been a bit focused on things that are even deeper than skills. So the wordings may change. Still, I have no intention of making the exam harder than it is. I'm obliged to tell you that we have a quality system. I have ambitions of giving a good course. Please help me. If you give me feedback and don't feel I react appropriately to that, then please look up this slide and see what you can do about it. Yeah. Why don't you choose the reference group now? One other category, in addition to those, I want to propose is the bad student. And not the bad student, and not the low ambition student. The student that doesn't aim for an A. The student that intends not to go to the lectures. Because I would want also to support that student, like to pass in this course with a minimum effort. Huh? Anybody? Hey, send me an email, huh? Please. Or you can suggest someone. Huh? Yeah, but I really want this, huh? Because I only meet the ones that go into the lectures. So and kind of getting the site from the other side would be interesting. Okay, then it's up to you. Give me these 3, 4, 5, 6, 7 persons. There will be pizza. Come on. You have to be represented. I don't think the NT News quality system insists on this. Yay! So you volunteer or you have a suggestion? Volunteer. Yes, great. Your name? Oh, Sverre. That's a nice name. I need a bit more. Storvoll. Yeah. Great. And what is your category? Elsis. Ah, great. 5-year cybernetics. Yay. Julian. Ås. Some 2 year. Yay! Both of you? Yes, great.
Emiliano?
Emiliano.
Yeah. E-Y-L-I-A-N-O Sotomayor.
And Pamela. Flores.
Huh?
Flores.
Flores.
Yeah, Flores.
Great. There we're over the minimum threshold. Who is not represented? There was at least Julian was 5 years cybernetics. Who do we have here from 2 year cybernetics? Ooh, am I written out of? Don't they have real-time programming any longer? Okay. Great, thank you. What we will be doing this week and the whole of next week, possibly the main focus also on the third week, will be getting the project started. It's not so that the project you're going to go to the lectures and use what you have learned in the project. The project is meant for you to become motivated for the theory, to be motivated for the problem. The project starts now or next week. We will not be putting the groups together. That will be the next slide yet. But start thinking already. My last slide will be well. So the exercises are mandatory, all of them. So some years ago, after Easter, I got one of the reference group members coming to me saying that, well, misunderstanding has spread among the students that the exercises wasn't mandatory. A rumor had spread. Yeah, so nobody has done the exercises, and if I could just let everybody take the exam. I don't. Let's hope that doesn't happen this year.
Yep. There are quite a lot of what's going on excursion. Is that?
Wait, we'll discuss. I have the semester plan. Yeah. Quality systems and everything. We are making changes. We are developing. We are adapting to the new times. Modern pedagogical thinking. We're increasing the group size from 2 to 3. More opportunities to learn from each other. You'll get a more challenging work distribution problem. Chances are that there are more to learn from the two others rather than to learn from the one other in the previous year's groups. Yes?
Are the exercises directly connected to the project? Are there
Half of them, approximately.
okay, are all the exercises intended to be worked on together as a group?
Yeah, except the one or two first ones, just because the group, configuring the group is a bit more complicated this year. So we'll have at least exercise 1 approved individually. Hey, I got, after my announcement of this at Blackboard, I got 2-3 emails on worried students. Whether, hey, I like very much working with my traditional partner. Yeah, so this is my reasons. I really didn't want the discussion. But I would rather have the discussion here and now than semi-endless email discussion. Yes?
I think you should have a Q&A to ask the people what they feel like is the best thing, because when it comes to the grades, I know people have different ambition and put different amounts of work into different projects. If you're not able to choose, you could end up with a terrible mismatch.
Yes. Yep.
Just to be past the I like working with my usual partner, you also have the logistics problem. Like some people might have already thought, okay, well, this has always been side groups, so maybe they've chosen electives so that their schedules match, and there are only set lab hours, and then if you then have random groups, then you end up maybe with people that actually come.
Yeah. No, we will be this week. Will be taking, hopefully we will be managing to taking care of both this, the schedule, the slot. We have four slots on the lab, and we will be asking you beforehand which on which days you can, so the schedule thing is one thing, and the other thing is the preferred language, because the project, you will have to make a decision on what programming language you will be using. So you will have to, like we will be matching people with the same interests. No, so this is a downside. I think for you here, the out of the 3 in the group, if you happen to get the low ambition student on the group, first, he will feel the pressure to contribute. And this is, seen from my perspective, a good thing. Seen from the university's perspective, this is a good thing. This is a good thing. Huh? Hey, I'm sorry about that. We probably disagree about that. But what we see in if you get to choose your groups yourself, yeah, we have this. We have some groups where both of them contribute, but most groups have kind of the easy negotiation. I'm best at this. Better I do the project alone. So then there is one doing the project, and the other one being not so well oriented. The ambition there isn't even that the weaker student learns from the better student. We really want this effect. Yep.
But don't you think that effect will just increase when you choose random groups? Because the one thinking he knows it all will probably put him on himself to do most of the work?
If you get I see the danger, but then the experience. I haven't tried this earlier, but the experience from my colleagues says that now the opposite in fact happens. It's if you're the good student, it's harder for you to propose. I'm the best one at this. Better me take the decisions. That's harder if you are with people you don't know that well. It's easier if you're with your buddy and he knows you're the better one. This cooperation should be a good thing. It should enable you to in fact share the load and find out how programmers cooperate. You haven't been exposed yet to projects being so large that you can't do them alone. It's good for you to have to share the work and keep the other one. This motivates dividing the systems into modules, and it motivates the other guy being kind of responsible for his module working. Okay. Who was it here? So you then.
Yeah, I agree with the first point in general. But as what you said now it sounds more like a course in cooperation than real-time programming. Because to do the course as intended for both parts, lecturers and students, we want both the best results, right? And to get the results both want, you have to be good at cooperation and motivate the other part with another ambitious. Do you agree?
No, I'm not certain I understood your worry.
For students to be good at motivating and doing the cooperation thing with big projects than doing real-time programming.
Yeah. What's it called? We have knowledge and skills, and there is a third column there, which in Norwegian is called generell kompetanse. Have you seen this? This is in our course descriptions. These are the three categories. It turns out that in English, this generell kompetanse is really well, including such aspects as selvstendighet og ansvar. What's that in English? Responsibility and selvstendighet. Independence, yeah. So in this category, we have goals as motivation, cooperation, communication, these things. They are not irrelevant even in a course like real-time programming. And as I say, the first learning outcome bullet point was general competence in software development. Hopefully, this will be your first software project of a size that where it's better to distribute the load between more people than it is to do it yourself. Certainly, software project that you can do yourself is easier. At least seen from the good student. Okay?
What I would do now is that if, say, people decide to groups themselves, and it's groups of 3, if someone then, or one student then thinks they're the better one and they want to do the main portion, and then the others, which then would know the person, if they then allow him to just do everything, then that's on them and that hinders their learning ability or learning outcome here. And but that's on them. And doing this, then you prevent others that may have achieved better student cooperation with people they know and produce a better result together with people they know than risk them joining groups where they don't know the other people, they don't have the same dynamic, and the produced result is worse than what they otherwise probably could achieve. So I think at this level, students should be responsible for their own learning outcome. So like if they then decide, okay, I'm going to let my friend just take all of the work and I'll just ride and wait, then that's their fault. And if then the exam goes poorly, then that's their fault.
Yes. Great. I see a lot of you nodding. Oh, I saw 3 persons nodding. That's good. That's student interaction, eh? I'm tempted to give you much right here. I'm the only one I know at NTNU that has this opinion. All when discussing, all the other people on the pedagogical discussions are of the opinion that mandatory activities is the way to go. Have you noticed that all this team-based learning and student interaction and learning by experience and all these things are mandatory? Of course, I can make you learn more if I fill my course with, I can make the lectures mandatory. I can force you to see the videos and check that you do before you arrive at mandatory lectures where there will be quizzes and grading. This is normal. The boring professor teaching from here, talking to a lot of students, is so out. I'm criticized for being conservative, old-fashioned. And my point here, this will not take more time. Maybe even it will take less time. It will be a more coordination. It will be more stressful to work with somebody that you don't, where you haven't negotiated the communication as well. Yes, but NTNU and and you know what your student representatives say in this question. Those, the student, like NTNU students, those that are your kind of political representatives, what they mean in this question, they say, oh, the lectures where the student may choose to arrive or not, they're so out. We really want the modern pedagogy. They want mandatory activities. So, while I agree with you, I I will be the last one over the next 10 years to force you to pepper my course with mandatory activities. But discussing this with my colleague, which I have done, the experience is that randomly put together group gives a better learning, and I can't see, it's not meant to take more time. It's but while many groups may have a higher learning, then some group may not. So it's a valid argument, and I'm sorry about the introverts. I had a lab partner in '83. I have done exactly half. I have participated in exactly half of all the exercises and all the labs. Every second I've done alone. This I can't say over lunch. But that's the truth of that. Yes?
I agree with the point that maybe if you take someone you don't know, that you might feel more responsibility to complete your part on your own. But you seem really focused that if we choose our own groups, that there will always be a good and bad student. And I can't quite see the logic in why a good student with high ambitions would choose to group up with someone with lower ambitions. Because it seems like it's supposed to be the good student teaching the bad student here, and that's a good thing for the bad student or the student with lower ambitions. But still, I think the goal should be every student to develop themselves. And if you get to choose your own groups, you can choose a person with equal ambition, and therefore you will avoid doing all the work for one person.
Yeah. But here again, you have your goals, and the university have its goals, and we may not agree on in this question, because I want also the weaker students to make the system so that also the weaker student learns as much as possible.
Of course, I agree with that, but still, it shouldn't be over-costing of the good students that they have to spend their time teaching someone with lower ambitions.
Hey, let me tell a story from this is medical doctors' education in Prague. They had put students in groups, six groups, and then on the oral exam, the professor singles out the weakest student and interviews only him and gives the grade to the whole group. This is a pedagogical trick that is in at the time. This is the way we are headed. This is a small step in this direction. But you know, the students in Prague there get good results. They're getting good results. Yeah, well, okay.
So just to build up on the argument, the way I hear it is that we see the one we're talking about sounds like two group students, but I don't think that us choosing our own groups necessarily should mean we only have groups of two. We can still have groups of three. That I think is an improvement because as software engineers then we get more of the team experience, like learning how to work in a team, like more than two people, which is I think very valuable thing. And then I also think that as we said, like I don't think necessarily means that like you would choose a bad suit and just let them drive away. And when it's then it would be three people.
But if you don't intermix the good students with the bad students, if we put a group of bad students in a, I'm sorry about, I don't know who's the bad student here, but probably none of you, seriously. If you put the weakest students in a room, less learning will happen. If we intermix you, more learning will happen. What shall I do?
Excuse me?
Yep.
I think you should differ from the bad student and the ambition part of it, because
Yes.
in the groups it's not about working with bad or good students. I think it's about working with the people that have the same ambition as you, people that you connect good with and have a good flow with. So it's not about having groups that are going to be just good people, because you work with people you like to work with. And not everyone is going to be on the same level. And if you, for example, look at the course we had this spring, the linear system theory, we this group of students got the best results they ever had, and we chose our groups independently.
Yeah.
You said it would not take more time. Why?
No. How much time you put into it is, and this we know, because this I can talk from experience. These groups from earlier years has a really bad ability to put the appropriate work down into the project. Really bad. It's 25%. You're evaluated in three times 8. I'm sorry about that. It's 25 in my course here. I think the 25th point, I don't think we can, we're not using that.
We do 8, 8, 9.
Huh?
We do 8, 8, 9 usually.
Oh.
9 on the...
Yeah. No, so from 0 to 8 points on the design, from 0 to 8 points on the code quality, and from 0 to 8 points on the functionality achieved. And the mean is 6 on each of these. So there are, from a mean average work, you're getting 6 points, and then you're talking about maybe managing, say, 7, 8 is barely achievable, or really demands really much work. This consideration, is it worth 2 weeks of full day work to get these percentages? It's not. This discussion I am not able to instill into the groups. When the deadlines approaches, then it seems like infinite work will be put down. Whether this discussion will be easier, I mean, the discussion might arise, is my hypothesis, in a group of people with different ambitions maybe, but where you don't know the people's ambitions so well, where things that may be unsaid with you and your traditional partner maybe have to be discussed. It can't be worse than it has been the earlier years. it's impossible to spend more work on this project. So, can only be less. Yep.
It seems a lot of people are worried about getting some kind of, I don't know, brain dead sloth on our group. No one here is got here because they have absolutely no ambition to do anything. So I think people should calm down. We probably will get good groups. Anyways, because I think there are only good people here. And I would appreciate if we can move on soon.
Yes, great. Thank you. Now, so we'll see what happens. Let's try this. There may be problems. Hey, I assume there will be more work for me handling problems because some of you will quit the course. Some of you will be low ambitions and not communicate very well with your partners, and we will have to handle that best possible way. So, okay, thanks for your feedback. I'll think about it. Now, so this is not the exact dates. We will be deciding the exact deadlines, coordinating with other courses you have, as well as we can. Please make when the first suggestions for real dates arrive, then give feedback just in case we don't detect all problems. But this is approximately what it looks like. We see the Easter and we see the excursion. But since lectures are Mondays, then I assume that the week before the excursion, usually you go away Wednesday or Thursday or something in the week before the excursion. So, but this Monday lecture should be okay. The exam is quite early, 20th of May. And the last lab exercise might be approved the week, or traditionally it's tricky to avoid that we need to have a exercise approval session in the week after Easter. Yeah. Yes?
For the people that are gone another week after Easter on an excursion, is it possible to get it approved before?
Yes, certainly. We'll allow for that. That's no problem. And yeah, so we will fix that. But you're telling me some people are gone also the week after Easter.
Yeah, I think.
Yeah. Yeah, I remember how it was to be a student. Yes. More to comment on? Yeah, 13 weeks of lectures. The semester is 14 weeks. So we'll spend the unused exercise hours to avoid having to have lectures after Easter, where it turns out people may not be coming anyway. So we'll use the unused Tuesdays exercise lecture time also for some traditional lectures. Okay? It's 15 minutes breaks and break time. So, the lecture plan exists. List of topics, approximate. The lecture notes, the slides are already available as they were in 2017. So they should be available at Blackboard. Or if not, make a comment and I'll fix it. This year's slides, including the slide I made today at 11:30, will be available as soon as possible. And my ambition is to make a new version, like to update the lecture notes along the way. So I'll update that irregularly, I guess. But so this is the approximate plan. There are more learning resources than you can appreciate. You have to make choices. It's not a book where you, if you read chapters 1 to 11, then you're safe. This is not how it works. So in 2017, we had a big discussion on how to use lecture time, because some students are such that they want to go to all the lectures and thereby achieve some sense of safety. I've been to all the lectures. I've done what was expected of me as a student. I have a good feeling about this. But given that the videos from 2016 was available, I was not motivated to trying to be a copy of the videos. That's the wrong way, kind of. So I was very motivated to look at the lecture time as a way to do something else. So, in my view, this enables a larger set of options for you. And, well, choices doesn't make people happy, it turns out. It looks great on paper, but I think this is a kind of scientific truth at the time, that a human with a choice is a less happy human than a human without a choice. Still has to do with responsibility and what was it? No, hey, read some old exam tasks. And the learning goals. When I make the exam, I will start at the learning goals. Solve some old exams. The exams, I will be telling you what I'm going to ask about. It should be. So I propose these three kind of ways to safety. And the last one, which is come to these Monday lectures and I'll tell you what you need to know. I'm not necessarily like teaching you, but I will be aiming to make it clear what you need to know. And the easy things are easy. The hard things, you can ask me to go through. Like student interaction, that's also very in. But you will have to make choices. Can you spend 3 minutes on this task? If you don't have pen and paper, or some of you may be able to think without pen and paper, it seems, but think about this task for 3 minutes. Decide how you would make this program. Yep.
Yeah. Is the goal to recognize what numbers are legal or not, or is the goal to just pick
No,
up the
pick up the numbers and print them. So, on the screen there should be 1, 2, 3, minus 233, 1.2, 0.05, minus 0.43, and then the so basically you should just reflect the numbers out to the, but you should kind of format them as, I guess, integers or floating point. Yeah, print the doubles. Okay, now I have one question. Raise your hand if you plan to make a state machine. 1, 2, yes, thank you, Anders. 3, I can call. Great. Those that attended my lectures in cybernetics intro 3 years ago, you remember what I tried to teach you. And state machines has been mentioned again and again and again during these 3 years. And we have failed to teach you it. I'm certain all of you can recognize a state machine if I showed one to you. What kind of software design pattern is used here? And you would all say, that's a state machine. We have events and transitions and state and the fourth thing. If I gave you this task and say, solve it with a state machine, you could even do it. I trust, at least, while maybe looking up what it was, and making the connection. How should we solve this problem with the state machine? And you will succeed. But then, this tool chest metaphor that I used in cybernetics intro, you should put the state machine design pattern into your tool chest, and then when the state machine represents the best way of solving a problem, then you should happily take your state machine from the tool chest and apply it. And this, we, not only I, because I've discussed this with my colleagues, also on Electro and IDI. We failed to teach you this. And this course is full of software design patterns and principles of this kind. So, 2, 3, but Anders doesn't count. So, approximately there. Hey, this is the exam results from 2013. Notice these two people. (2014), ooh, that guy. The other one was sick that day. But here, the scale is different. So we have 2 there. Ooh, here they are again. These 2. 16. There they are. I'm not joking. And here it was you and, those 2. Now, my ambition is to be able to make this group larger. I'm convinced that just as the state machine thing, those that made this group like existing in the sense that it's an open space here, I think that corresponds to the answer to the state machine design thing. This is the deep understanding. This is like knowledge about how is you can tell me what a state machine is. This is knowledge. And then you have skills, use a state machine for something. But being able to see that this problem is best solvable with a state machine, this is the ambition of the course. This is my plan for improving myself as a lecturer. I kept 2 hours of studietechnique, so-called study techniques, for the first year students this fall, where this was kind of one of the conclusion slides. How do we learn these things? Hey, I'm not even certain that those 2 guys learned it from me. I have really, certainly, I couldn't claim to be the ones teaching state machines to those 2-3 people, or Anders. So, but the way we learn, such things is, hey, role models. This is how you learn from your parents during childhood. You absorb after endless number of examples on how to behave, you absorb. When you have implemented enough different problems with state machines, you will be able to abstract, to recognize the problems that state machines can solve. But this requires you doing all these examples. Then, creating awareness, if you say, oh, there's something here. Some people, hey, to make a long story short, hey, would you be interested? This is study technique. This is how the attitude you need to have on Mondays to be able to absorb the software design patterns on real-time programming, multithreading, fault tolerance, because this will be more advanced than the state machines. Now, certainly you will be able to pass the course with only knowledge and skills, with only knowledge. I mean, the exam format is made to test only knowledge, so yeah, certainly, but getting an A in this course is hard, and I want more A's. So, anybody feels triggered by this slide and want more? Nah, great. Tell me by email at a later time. Then, hey, we're making, hopefully, we're making videos. Would you be interested in even more learning resources? Yes?
What would that be?
This is the video of what happened here today.
No, even more learning resources. What do you mean by that?
Even more learning resources. This is making this list longer. The things you can choose from to prepare yourself for the exam and to make yourself safe. Tia, Anders?
No, I'm just promoting myself as a learning resource.
Yeah, Anders personally is a learning resource. Yes, great. Also me. Send me emails.
If somebody wants me as a learning resource, maybe I get paid.
Yeah, so there was some nodding, which means that the back of your heads may in fact end up on the big internet, and you're coughing, and we'll see about the microphone, and I understand the department has. We'll see. Let's see how the filming worked today. But I'll try to make them available then. We'll and continue filming. And then limited by yeah. No. We'll see how it goes. I'll aim. My last slide. Is this even possible? Yes. If any, yes, thank you. Yes, it is. But it requires a change of perspective. If any if statement in your program can be invalidated by a bit flip, how can you claim that the program does as the specification says?
Use statistics.
Good word. Yes. Yes. No, we'll go through this. This is almost half the course. And you know the specification of the project. The project control cooperating lifts. And I'm in the hotel where these 3 lifts are. And I'm going into the lift and say I will be brought to the 4th floor. And if I don't end up in the 4th floor, I starve to death. And you have killed me because I'm not pressing a button again. Under no circumstances should my button press on the 4th floor button be forgotten. Under no circumstances. So this is the project specification. And all the techniques to make this work, you're not going to explore all of them. You're going to make an attempt of this, and you're going to motivate it by the curriculum. And these are patterns of the same type as the state machine. And my motivation for coming here on Mondays is to try to convey this impossible thing. Okay, any questions for me? We have 15 minutes of the scientific assistant, and we have 1 hour with Anders introducing, talking about what Anders wants to talk about, the project probably. Yep.
You said that the lectures from 2019 this year is not a complete walkthrough?
No.
But what about the videos from 2016?
Yes, a complete walkthrough.
Okay. So if you just rely on them, that's it?
Yes, and then you can use the Monday lectures to come and ask the questions you have as a backup. Yes.
The next question is, where can I find this?
There are PDF. We have 2 PDF indexes to these 2016 lectures. They are on Blackboard, and they are sorted on what is the contents of each of the lectures, and on the topics from the lecture notes sketch. Where is this stuff being walked through? So the indexes are quite good. And I think they are on Blackboard, at least, yeah. So if not, protest or what's it called, blame, then we will fix it. Okay? Ja, så ikke sånn velg kilde og sånt? Nei, jeg kan stå foran. Jeg kan Hæ? Ja. Petter, senor, lommamenn, og lykke til med den.
Okay, some practical information. We will divide you into lab groups of 3 students based on a survey of your preferred lab slots, programming languages, stuff like that. This survey will hopefully be posted on Blackboard relatively quick. These are our lab slots. We have 1 slot on Monday, 1 slot on Wednesday, and the 2 slots on Friday. We might also get a slot on Wednesday, maybe. There are 10 exercises, all are mandatory. Exercise 1 will be done individually, the rest will be done in your lab groups. Ignore this part, all exercises are required for exam entry. Exercises 4 and 5 are also part of the project. You will have your exercises approved by a student assistant in your lab hour, and you can have exercises approved at most 1 week after the stated deadlines, which are here. You also don't need to complete 100% of the assignment to get it approved, but make an effort. The elevator project will count towards 25% of your final grade. There will be a total of 25 points available, split into 3 parts, listed here.
I see the 25th point is coming.
Yes.
Yeah.
The design review will be a short presentation where you will tell us about your design decisions and we will ask you some questions. In the code review, you will first give and receive feedback from other groups, and you will also receive a final evaluation from ourselves. And finally, the completion test will make sure that your system meets the specifications. These are our preliminary deadlines. They might change somewhat. Exercise 1, which will be posted later today, has a deadline next week, and you also have 1 week after that to get it approved. The design presentation will be in week 6, code review in week 10, and the final acceptance test in week 12. Final point, we will hopefully be using GitHub Classroom for our exercises and projects if we can get our academic discount approved. But we would still recommend you use Git for version control, at least in your project. Finally, last year's project is available on this link. We will be making some very minor changes, but most things will stay the same. And this second link is a good introduction if you're not familiar with Git. Okay, I think that's all.
That was your 15 minutes?
Yeah.
Oh.
Yes?
Yeah, these scores for the design reviews and the code reviews.
Yeah.
We received similar scores for the embedded course we had. And they were given with 0 context. Will we be receiving some sort of context with these scores, or will there just be the score? And will we have to guess what we did right? I can answer this.
No, so Anders will be ask this question to Anders. We have a microphone problem now, and Anders will be the next one speaking. Repeat your question then after the break.
Okay.
Any more questions?
I'll stand here and then shout. Oh, Anders could have shouted also.
Yeah.
Hey, more questions for us, or we'll take an early break and give Anders the time from 5 past. Okay, everything's clear. Then see you 5 past.
Yes. Okay, so the plan was do a little bit of a live demo to demonstrate the set of problems, or a set of problems that we will encounter in this course. Of course, time happened, and then we're just going to do that demo tomorrow instead. So let's just pretend we've done a live demo and we've countered some problems, and we're going to talk a little bit about the concept of problem itself in the context specifically of the exercises and the project. The way I've set it up, because I made the exercises, and well, I didn't make all of it, I updated them significantly. And the way I've thought about it is you need to encounter the problem first before we give you a solution. If I give you a solution first and say, here's a puzzle, by the way, you need exactly what I just told you, do exactly what I just showed you. Well, it's like giving you a pill to cure a headache that you don't have yet. It's pointless. It feels pointless. There's something about it that just doesn't sit right. And it happens a lot in math courses where they just tell you, by the way, here's a bunch of theory. Oh, do the exercises. And you're like, oh, I just need to use this theory that I just learned. And it just, there's something about it that isn't gripping. Because there needs to be a balance between too much problem and too much solution. If you're leaning too much towards the solution first, it feels pointless. And if you're leaning too hard into problems first, it feels frustrating because you don't know what to do. There's a territory of the known things, the things that you know. Well, we can do the full Rumsfeld. We can do the known knowns, the things that you know that you know. Then there are the known unknowns, the things that you know that you don't know. Then there are the unknown unknowns, the things that you don't know that you don't know. And then I guess there are also the known unknowns. No, the unknown knowns, the things that you don't know that you do know, but you actually know them. You're just not aware of it yet. So think of it this way. The known knowns, that's what's within your horizon. The known unknowns is what lies just beyond the horizon. And the unknown unknowns is the horizon beyond the horizon. You don't know that there is a horizon beyond the horizon, but there probably is. And then the unknown knowns, I guess, is what's behind you. You just have to turn around. Right? It's right there, but you don't see it right now. So all of this is about perception and paying attention to your surroundings. Okay? Okay? And the other thing is that the place that you want to be is moving towards the horizon and always looking at the horizon. Right? So my goal is to make sure that as the course progresses, you move towards the horizon for this course and you start seeing the horizons for other courses or other things that are not even in these courses. And in order to achieve that, we have to start here, not knowing what is at the horizon and not knowing exactly what direction we're supposed to be going towards that horizon. Which means that right now, when I tell you about the project things and the exercises, you're gonna say, how in the fuck do I solve this? And that's normal, and that's on purpose, and it's expected. So I'm gonna take the liberty to go on a bit of a tangent here about how to study for and how to work on a project like this. We're gonna cover more of it later because it needs to be covered in some code quality material as well. But last semester, I was the scientific assistant in the real-time systems course, which is, I guess, the next logical building block for this course. It's an operating systems course, mostly, and it covers more scheduling stuff and more hard real-time stuff, less fault tolerance and less elevators. And there's a small project there as well. It's much smaller. It's a 2-week project. I made I'm not sure if it was smart or if it was not smart, but I extended it and said, fuck it, it's 4 weeks. And what happens is people used 4 weeks. I mean, what did I expect, really? But we're going to come back to that one as well. But the thing is, the student mass is always divided between the ones who are naturally engaged with the topic at hand. People are specifically interested in things. And then there are those of you who are just like, this course is mandatory and I just have to take it. I'm not particularly interested in this. I want to go into the control theory stuff and computers can go fuck themselves. And that's fine. I can't stop you from feeling that way. That's just the way it naturally is. But what happened is I had a couple of students there which from the first week I just felt like these were like natural A candidates. These were going to get A's in the course and they were going to absolutely cruise through the project. And guess what happened? While I take a chug of this, delicious, 820 hydrates, as opposed to like 420 blaze it, I guess. What happened to the group who thought they were, or who I thought were, extraordinarily overcompetent for this course? Well, there's two natural, nobody's suggesting anything, so I'm just going to suggest anything. There are two natural things that happen. Either they actually are good and I wouldn't be telling the story, or something bad happened and I'm telling the story. Because what's the bad thing that happened? Well, what I usually do when I'm on the lab, and I'm not sure how much I'm going to be on the lab, depends on how much I get paid, I guess. Well, please pay me. I go with the rounds. I make sure that I talk to every group. That's going to be hard when there's like 1,000 of you. But in this course, there were only 59, so it was doable. I go around to every group, and every session, I make sure that I interact with every group. That's the goal. And then there was this overcompetent, or at least what I thought was overcompetent group, who just kind of gave me the impression that they just didn't want to have me around. And that's fine. I can't stop that from happening. But there were other groups who, like usually you get up, find a student assistant and ask them a question. These guys didn't even have questions. They were just like, hey, I want to show you something. And by the way, if that guy who was doing like the elevator with as few lines of code as possible, or with just the 2 curly braces for main is here, from last semester, is he here? I just want to say sorry for not getting back to you, but okay, never mind. Like that kind of special engagement that I also can't control. The two completely separate groups, overcompetent, didn't ask for help. When I tried to give them help, they more or less rejected me. Feels bad. And then this other group who were, I would say, middle of the pack, like in terms of what they knew ahead of time and the things that I had to teach them, but they were always engaged. And the overcompetent group, well, they delivered, I would say, I wouldn't say that. Well, I would say this because I did evaluate the project, but it was the worst project of the bunch. And the question is, how did that happen? Well, they were here, they saw the horizon, and they didn't move. They didn't pick any direction to move in. They just stood there. And I can't stop that from happening. You can try to stop it from happening to some limited extent, but if you aren't interested in something, you can't move. Like, no matter how engaged someone is about knitting, I will not be particularly interested in listening to them for 3 hours about knitting, maybe about other things. The same as like mixed martial arts, like I don't care. And you can't really make me care. Sorry, Joe Rogan. Chimpanzees, on the other hand, keep talking about those. I like him. So, ultimately, the question is, why do people not ask questions? Because that's going to go back to the thing that was asked or commented on very early in this lecture. What happens if you have one good and one bad student in a group, and the good one feels like they need to carry the bad one? Well, the good one doesn't have anything to move towards. Well, we're here. There's 3 of us here. Then there's a student assistant, and then there are other people who are not necessarily in your group. And all of these people might be better than you. All of these people might help you get somewhere. But you need to ask. You need to engage. So what's stopping people from engaging? Well, I've tried to figure out how this works. The first thing I thought of was people try to make or teachers try to make the students engage by saying dumb shit like, "There's no such thing as a stupid question." Who here has heard that one before? Okay, who here truly believes that there is no such thing as a stupid question? Like, come on. Of course there's such a thing as a stupid question. That's not the point. The point is something different. It's just phrased poorly. What it actually means is when you're trying to ask a question, it's because there's something you don't understand. And when you don't understand it, you don't have the vocabulary to formulate a proper question around it because you don't understand it. It's like saying, hey, can you define this thing that's beyond the horizon that I can't see yet? That's what it means, no such thing as a stupid question. It's just, you can't formulate a proper question, so help me formulate. Let me help you formulate that question for you. But you need to ask it first, no matter how stupid it sounds to you and to me initially. That's the first thing. Second thing is, you're in a room now of, let's count, 1, 2, 70, 159,000 people. And you're like, I don't want to make a fool of myself in front of all of these people, so I'm not going to ask questions because I'm sure everybody else understands it. Pro tip, no they don't, but I can't make you feel that properly. And then the third thing I thought about was there's like a classroom dynamic thing going on here where I'm on this side and you guys are on that side. You're all facing towards me and I'm facing towards at least some of you at a time, not all of you, that's not possible, but there's a set of rules in this room. Rule number the first, you guys sit down and shut up and I talk. Rule number the second, you're allowed to talk. There's something that doesn't work there. Because the second rule kind of contradicts the first rule. Because what you're doing when you're asking a question is you're not necessarily breaking a rule, but you're kind of breaking the dynamic that's going on. Well, let's figure this one out. I've heard about this like this inverted flipped classroom thing, and I'm not quite sure which way you're flipping, but I'm guessing it's this way. So what happens is you pull the students further forward and the teacher further back, I guess. And the question is why? Well, question 1, does it work? No. Question 2, why does it not work? Well, because there's an expectation that on this side, like from this line and backwards, there's something that does not exist on the other side. There's an expectation that I will tell you things that are true, valuable, and useful. And all of those three things are actually the same thing. There's an expectation of utility from, or information, utility of the information that I will give you in that direction. And if you put the students over here, you realize that those students actually don't know anything more than I do, and then it doesn't work. So when you're asking a question, what you're actually doing is you're questioning the utility of the information that is being presented, or even worse, you're questioning the person who is presenting the information. You are inverting some kind of power dynamic going on in the classroom. That makes it scary. But what you have to realize is, there are probably people on that side which are older than me and know more things about other things than what I know. I'm not the most experienced guru of all time, right? I have also been through the process of learning these things. He's also been through the process of learning these things, and there are things that we do not know, right? There is actually a two-way flow going on. I was his student some time ago, and I'm sure you've learned some things from me as well. So, conclusion time for asking questions. Ask questions. Number 2, find a situation where you are comfortable asking questions, particularly the lab, where you're doing the exercises in the project, of course. And if you want to remain even more anonymouser, emails and such. But remember, if you want to actually not be the one that's stuck going nowhere, you have to engage at some level with something. And if you don't find that enough with your partners in the project and exercises, you need to find that elsewhere. Always be moving forward. So, let's talk about some of the problems that you will encounter in this course. This is where you're pretending that a live demo happened. Okay, are you prepared to? Okay. Examples of problems. In this course, we're going to expand your programming horizon for at least most of you. Those of you who are exchange students and took the real-time systems course, you don't get such an expanded horizon because you already know this, a lot of this at least. We're going to start programming multi-threaded. So for now, if you've been following the 5-year program, you haven't programmed a single multi-threaded application yet. And we're going to start programming multi-threaded. And then the question is, how do you run things at the same time? What does at the same time mean, and how do you separate things that are not related to time into things that are related to time so that you can think about the same time? Complicated stuff, really. And then, of course, the corollary to this one, how do you prevent stuff from running at the same time? Because sometimes you want to make sure that you only run one thing and not 2 things at the same time. That makes it even more complicated. We're going to talk about programming itself, the act of programming, the goal of what it means to create software or create software artifacts, and also consider all the different qualities of code. Short version, there are qualities like, does it work and is it power efficient, which are completely objective qualities. And then there are other things that seem like they are subjective qualities, like generic code quality, which turns out, at least from my perspective, you can actually organize them into reasonably objective criteria. And I will try to cover that in one of my experimental lectures. Hopefully I get to hold one. Please pay me. Sven is going to cover code quality from how would you describe your perspective? Let me just move the microphone over here. How would you describe the approach?
So, maintainability.
Maintainability.
You can take it from there.
I was hoping you would be like, oh, I'm going to use a book or something.
Now we have the code complete checklists.
You have checklists, so kind of like rules. Like do this and don't do this.
But the maintainability is the baseline, the rule, the overarching argument. Yes.
So you see what's going on. There's a hierarchy of different rules. At the top, he puts maintainability. Personally, I think that's a little bit vague. I argue that the highest point is simplicity, which is a bit more objective. So there's slight different perspectives and slight different approaches. He approaches it, I think he approaches it more from from the bottom up, looking at the rules, and then these satisfy the maintainability criteria. And I look at it more from the top down, like human perception type level shit. It's like I'm not sure what I'm going to title it yet, but I think I want to hold a lecture called Object, Pattern, and Perception. Just like, yeah, okay. And then I also want to hold one that's called Abstraction and Meta-Abstraction, but that one's, okay. Next problem, we're going to try to separate, oh no, you just learned object-oriented programming, didn't you? Oh, what a shame. We have so much to unlearn. What a joke. Okay, so you're going to have to unlearn all of that. Just forget everything. If you took that course and you're like, I did really poorly in this course, I'm going to do poorly in all programming courses. Don't worry, I also did poorly in that course because it sucks. It's like everything you just learned is a lie. Okay. But at some point we do actually need to group data and execution, and the grouping criteria are completely different than the ones you've already learned. So, we're going to compare lambdas and objects and see which one is superior. I'll tell you which one's superior. Monads. Okay, those are just execution though, so there's no data involved. How to choose what runs when, we are going to cover scheduling, are we not?
I think so.
He thinks so. Okay, well, let's pretend that we are at some point going to cover scheduling. And we're going to cover hard real-time and execution. Yeah, okay, so how to make we have a deadline. We need to make sure that something is done by the deadline, because I like this joke. There's people working like on nuclear warheads, computer systems for nuclear warheads. And if something goes wrong, millions of people could live. We're also going to make reliable systems with unreliable parts. That's mostly what the fault tolerance part is about, and also incredibly important for the project, which we will discuss soon. And then we're going to do this fun one, which is how to fix bugs that we don't even know are there. That doesn't mean you're not allowed to fix the bugs that you do know are there, because you can fix all of them, but you can also fix the ones that you don't know are there, which is fun. And finally, the one everyone hates. Ugh, God, people suck. And also, but of course the corollary, how to work independently together, because hopefully you're able to distribute the workload among you so that you're not all working on exactly the same thing at all times. Hopefully. That way you can work not together as well. You can ignore each other together. Yeah. Okay. So let's talk more specifics about the projects and the exercise. Any commentarinos so far? No, nobody wants to participate. Okay, unlucky. I'm not sure how much you already know about the project, so I'm going to cover it in moderately low resolution. So this is the elevator, which you have. Who here has not seen, or who here has not seen the elevator before? Okay, who here has not used the elevator before? Some more of you. Of those people, I am expecting there to be people from electrical systems people and exchange students. Are there any other groups? 2-year master. So you do exist. I thought we established that you people didn't even exist anymore. Okay. Well, here you are. Okay, so those 3 groups. So everybody else has already done a single elevator project, which is, well, it should have been create a state machine that controls an elevator that goes up and down and takes orders and lets people on and off using this mock-up hardware. We'll cover that material if you are not familiar with that material. Resources to help you learn that material as efficiently as possible does exist, and you should ask if you have problems with the efficient part. So here's the overview. I'm just going to do all the things at the same time. So we now have more than one elevator. We have a set of elevators connected via the network. The problem is, of course, that the network sometimes just doesn't exist, because we happen to trip over a network cable and it's like, oh, whoops. It's a great elevator system, by the way. People are just tripping over network cables left and right. Technically only left. We only trip over one network cable at a time, but don't tell anyone. Also, the power is unreliable. Jeez, sometimes the motor on the elevator just doesn't work. That's a shame. What happens with the people that you've guaranteed that some people are going to be picked up? They're waiting for an elevator, and then the elevator that you assigned to go pick them up just doesn't work. What do you do? Oh, also the network doesn't work sometimes as well. Cool. Also, you get to choose any programming language for this. And the question is, why do we let you choose any programming language? Well, the short version is that programming is a way of formalizing ideas. It's you taking something that you want to create and you're translating it into a formal framework, and that framework is the programming language. And then there are some programming languages that are especially suited for one thing and not suited at all for other things. For example, creating a game engine in PHP. That is something that doesn't sit right there. So the way you think about how you want to implement things should hopefully influence the programming language that you choose to implement it with. Because you don't want to fight the language, you want it to work with you. Which means that you need to explore a couple opportunities and explore the space of available programming language to the point where you're comfortable making a decision. You don't need to explore it much further than that. The problem is that I feel people are too eager to make that decision before they are actually ready to make that decision, and they are also not eager enough to go back on their decision and change the programming language after they've invested, I don't know, 2 minutes in starting the project in some other language. It's like, oh, but I've spent 30 seconds, I can't swap now. It's like you can spend 2 weeks and swap later. Don't fall for the sunk cost fallacy. You can, if you know exactly what you're going to do, you can implement the elevator project in, I don't know, 12 hours. You need to know exactly what you're going to do first. That's the hard part, and that's not programming language dependent. So, yes.
How big is the range on like the language that the group select?
How big is the how different are the languages?
Yeah, or
okay.
Is it widely spread, or is it like one or the other, or like?
Oh, well, okay, here's what happens. There's a social dynamic fad trend type thing going on where students see other students pick languages and they pick those languages because other people pick them, and then they also see what the student assistants wrote in, so they pick what the student assistants wrote in, and so there are like these trends that go over time. So what happened was when I did the projects in 2013, yes, that's 28 years ago, or 39 if you're working in imperial units. Most people were writing in like C or C++ variants because that's what they knew. And then Golang, which is Google's message passing Mickey Mouse language, it's basically C with message passing. It's missing a lot of useful stuff, but they want to keep it bare bones, which I can understand their ideological position. I don't agree with it, but I can understand it. So this became very popular, and then the student assistants were naturally the ones who had used that, and so that influenced the next group of students, and we ended up with like 99% Go. And then we got some like really good students that decided we're just going to do it in Erlang, and we went from 1 Erlang group to 2 to 4 to like 20 plus last year. I don't know. So I don't know how many Erlang student assistants we have this year. So there's a trend thing going on, and then the other thing is that there are people who just don't care about trends. So C is basically down to 0, where it should remain. Well, C doesn't have any things that help you write multi-threaded programs, and it doesn't have anything that helps you write network code. So obviously it's a bad choice for something that requires, I don't know, multi-threading and network. So I wouldn't choose it. Go, on the other hand, is designed for multi-threading and network, so it seems like a reasonable choice. Erlang is also designed for multi-threading and network, but it is a functional programming language. In other words, you can't write A equals A plus 1, because you just said that A was the previous thing, and now you can't say that A is the next thing, because that doesn't make any sense. You can't say that A equals 5 and 6 at the same time. What are you doing? Right? So there's no such... You can't do that, for example. There are no loops in Erlang. There's only recursion. Okay? So it's a different way of thinking. But then there are other people who just like don't care. So we had one group who wrote the project in Racket, which is a Lisp dialect, which is designed for creating compilers. It is a compiler-compiler language. So what they did, they didn't write the elevator project, they wrote a program that compiled the code for the elevator project. So they were meta-programming their way to hell and back, and they created something that works, and I have no idea how it works. I don't remember what I gave them for code review, but it was probably high, just because I was like, the parts that I do understand are correct, and the parts that I don't understand, so I can't comment on them. And it's so ridiculously out there. But then you also have some people who are like, well, I feel comfortable using Python. And I'm like, you sure about that? I was like, yeah, it's a simple programming language, and I've used it for every course before. Yeah, well, you've also used MATLAB. Okay, so the correct solution is, I shouldn't say this because I also want you to explore other opportunities, but the correct solution is something like Go or Erlang that has message passing. But there are also other programmings that also have message passing and a ton of other stuff like D, Rust, Scala, C++, arguably if you want to use some libraries, but you know, it's out there. So the opportunity space is larger than you expect. And I want to see a Haskell project. Like, come on. I want to see a Haskell backend with a Python frontend just for the fun of it, you know? Yeah. So yeah, there is a spread. It's not as large as I would want it, but I can't complain, right? Because people are ending up towards sensible solutions. So there are no more C groups, which is what I wanted to achieve. Personally, he probably doesn't agree.
I have my own opinions.
Yeah.
Me and Anders don't always agree. You'll have to live with that.
Yeah. Okay, let's look at the specifications for, did I answer your question, by the way?
Yeah.
Okay, I did answer the question. Wow. Okay. This is the TLDR for the specification. I don't know, are we doing, Mr. Vitas guy on his phone? Hello? Wake up. I have a question for you. Are we using the 2018 specification that Kjetil created, or are we using this 2017 specification that I created?
Tricky.
Well, the specification is the same, but the way it's formulated is different. Okay, let's do a poll. Let's do live audience poll, interaction, democracy. Yeah, let's get it. Okay, there are two different ways the project is specified. One is in plain text, like English language, like what you see up here. The other is much more formal and much more rules-oriented, but it's perhaps more exact but harder to read. Okay, so who wants to go for easy to read but sometimes vague and you have to ask questions, and who wants to go for completely exact and you may also need to ask questions in order to interpret it? So who wants to go for vague but natural language, English? Let's see some hands. Who wants to go for very precise but not quite as natural language? Okay, this is so vague, I need to do the George Robb. Well, both exist, I just want to know which one is primary. So let's do the George Robb single clap. When I say, you clap once and we judge it by volume, okay? So are you guys ready? Okay, vague, 3, 2, 1. Very exact, 3, 2, 1. Well, I guess we're doing both. Well, the specification is, as I say, the same thing, or at least they should end up with the same thing, but the way it's formulated is slightly different. But okay, what have I written here? I mean, it's, as I said, 29 years since I wrote it, so. Yes, no orders are lost. If you push a button, what is supposed to happen is, of course, that the light in the button turns on to confirm that the button is in fact pushed. When you deliver this confirmation, you are not allowed to retract it, because if you do retract it, millions of people will live. No, one person will die. All orders are computed or delivered within a reasonable amount of time. There's some vagueness what is reasonable in this thing, but you can't just say, oh, well, the light is turned on, so it might be delivered within infinite time. You never know. It's like we're dealing with on the order of seconds to minutes here for what is defined as reasonable. Multiple elevators should be more efficient than one, so you can't have two completely idle elevators and one that does everything. The goal is here just to you need to demonstrate to us that you have actually done the networking portion here. And so there needs to be some way to confirm that there is in fact communication going on between them under normal circumstances where the cables are in fact plugged in. And of course, a single elevator should behave sensibly and efficiently so that the call up and call down buttons actually work as it's an elevator. It's not like what's the Jewish holiday? The Sabbath elevator, where the elevator just goes automatically because nobody can operate it because you're not allowed to work on Sundays. Or is it Saturdays for Jewish people? I can't quite remember. One of those two. But that's actually a real thing in New York, where it's like elevators will just stop at every floor because you're not allowed to push the button because pushing the button is work. And you're not allowed to work. And there's legit religious reasons for it. But well, I can't argue with it. It's their tradition and it works, but you're not allowed to do that in this. No Jewish elevators? Wait, that doesn't sound right. That doesn't sound right at all. I'm not allowed to say that, am I? Okay. Did I cover this? Oh yeah, I did cover this. Yeah, I did cover this. I also covered this one. Don't fall for sunk cost fallacies. Okay, support material, because I do actually want you to finish the project at some point, surprisingly. There's a simulator, and the simulator is, I think we can actually say that it is now confirmed to be good enough to completely replace the hardware elevator at the lab. Because there was last year a group that used exclusively the simulator when developing, and they scored a full score on the completion. So this means that on the lab, when you need 3 elevators to test with 3 elevators, you don't actually need 3 pieces of hardware, because that eventually that doesn't add up when everybody needs 3 pieces of hardware and there's 25 groups and only 25 pieces of hardware. Like there's like 3 times not enough. Or is it 2 times not enough? Depends on how you define it. Do you define the overlap or not the overlap? Okay. So this will definitely help you work both on the lab and also from home, because the simulator also works on Windows and Linux. Well, I didn't write Linux because that's obviously works on Linux. Everything works on Linux. Low-level network code. This is not a course in networking. Well, it's not a course in low-level networking infrastructure like IP and the hardware layer and stuff like that. So we're going to give you that stuff. But the thing is, whatever you do with network, it will never be so, you can never program it to be so reliable that we don't plug out the network cable. I don't think you can program us to not pull out the network cable. I mean, you can try, but I don't think you can actually program us. So at some point, making it reliable will be up to you. So we're not going to give you that. And then the elevator algorithm. Because again, this is not an algorithms course. We don't want you to spend an absurd amount of time doing algorithm work. We'll give you some ideas and some direction to move in there, so you're not exploring territory you don't need to explore in an inefficient way. Like, no, that joke doesn't work. Never mind. Evaluation is in 3 parts. We are now getting to your question, sir. Eventually, we got there. So, there are 3 components to the evaluation. The design evaluation is sometime in the middle of the semester. So it's not after you are done, and it's not so early that you have no idea what you're doing. We're trying to hit that sweet spot where you're comfortable enough saying that this is what we want to do. And then what happens is we evaluate you based on how well you understand the problem, but we also give you feedback to make sure that you are moving in the direction you want to be moving in, or we want you to be moving in, I guess. So there's 2 complementary parts there, which are hard for us to balance, because we need to both evaluate and, I want a word that rhymes, and motivate isn't the correct one. Okay, well, you get the point. We want to give you feedback as well as evaluate. And then completion, which is at the end, together with the code review. These are both at the end. I'm not sure if the dates we've set are completely fair yet. We'll see how this lines up. The completion is just to see, does it actually work? And we have a list of things that we are testing, and we are not giving you this list. We are giving you the specification, and we will only test things that are on the specification. We will not actually be, well, it's up for debate, I guess, technically, but not with me. But I'm not responsible for not giving it out or giving it out. But I would argue that we should not give it out, because what's going to happen is people are programming for the test and not for the specification, which means you end up creating all these like specialized little ifs here and there to make sure that you capture all the specifics of the test and not actually programming proper software. So that's the reason why that's the reason why I don't give you the completion test criteria itself. But there will be no surprises, let's put it that way. And then the final part is the code review. And the way we've done it in the past few years is that this is peer reviewed. Have you been through a peer review, code review process before? Did you actually? I see some nods. Who has? Who has not? Okay. So the way it works is you get a set of projects and you get a set of criteria that we develop during the semester on how you should evaluate code. And you evaluate each other's code. You also evaluate your own code based on the same criteria. So that's always fun. Let's see if you can give yourself a full score. And then we use some back-end advanced statistics to make sure that people are actually not griefing, I guess is the correct term here.
But what if you say that everyone decides to go Erlang language, and you're the one special snowflake that wants to go C, piss you off, but then will you then get...
Well, what happens if you decide to be a special snowflake and write in this language that nobody else writes in, is that you will have to evaluate a non-special snowflake language that best matches your special snowflake language. And then, in addition to that, I will be involved in evaluating you. And I am not, I have a high bar as well for code quality. It's, yeah, I have a high bar for code quality. You can get there, and I will help you get there. But the bar is pretty high. So yes, we have our methods. We have experience, like the same with the Racket group. That was a lone programming Racket, and we're like, how many people do we expose to Racket just to evaluate this? And we decided the answer was none. Because they would end up spending 2 hours trying to figure out nothing, really. So.
Hey, but the exciting languages are encouraged, just out of to avoid boredom.
I mean, as I say, the bar is high, but you do effectively kind of get ish bonus points in the sense that if you do pick an interesting language, I might end up being more involved in your project than you might, want. Because I want to learn stuff as well. So if you pick something I've never seen before, I'm going to show up. That just kind of happens. Yes, but as for the feedback part, which was the question, how much of this do you get back? And the answer is hopefully all of it. You get to see what other people have evaluated. You don't get to see who, but you get to see what. Okay. Yeah. Exercises. Is that your phone? Oh. Well, I'm so glad we can just edit that part out of the video. So, okay. So, there are two kinds of exercises. We've briefly covered this before, so I'm going to do this fast. There are standalone exercises which require approval. Then there are project exercises which are just milestones for the project. These do not require approval because if you do the project, you will have them approved. And then there is a list of exercises. The thing with the milestones. The milestones kind of run out after a while because eventually there's so much freedom and so many directions you can go in and so many things you can do first and then do other things afterwards. We can't force everybody into a mold. It doesn't work. So eventually we run out of milestones. And you'll have to figure it out on your own. Exercises list. I didn't include exercise 9 and 10 because I didn't get time to edit my slides between the breaks. These are the exercises as they have listed up now. Exercise 1 and possibly also 2 are done individually just because we haven't combined groups yet. And I will be covering exercise 1 and 2 material tomorrow at 2 in some lecture hall, which I haven't checked which one is yet. Number 9, which isn't written down, is scheduling and response time analysis. Number 10, which is also not written down, may or may not exist. We may end up with only 9 lectures, and this one is modeling of concurrent processes is basically the short way of formulating this one, or specifically modeling of message passing concurrent processes, I guess. Did I see a hand? Oh, it was just like a random stretch. Okay. going to spend the last 10 minutes going through the breakdown, because eventually you will have, well, hopefully not. There is a quote here. I want to cover this quote. The context for this quote is actually somewhat important, but it's also not important, because I think this quote is really cool. I love this one. Okay, so what the context he means it in specifically was in data, as in raw data for your program, because your program is basically separated into data and execution. And when you have data, you don't need to wrap your data into anything. You don't put your data into, don't make a new class for every piece of data. It's completely unnecessary. Just leave your data as it is. Data is simple. You don't need to combine it with anything else. Just leave your data alone. The only thing you can do with information is ruin it. Great. But I think it's a bit deeper than he intended it to be. Because you see, listen chat, listen. Where am I? Okay. You can think of computers as data plus function, but the function is also data. Because, well, your functions are stored as machine code. Machine code is data, so what your computer actually is data plus energy. You're just taking energy and manipulating data through energy. It's kind of like guided entropy. That's what a computer is. So, what are you doing to this data? Well, you're not creating any new data. That's not how entropy works. You're reducing the data. You're always reducing. You're always going from lots to little. You can't create anything new. Even random number generators on computers are pseudo-random number generators. They don't actually input anything unless you get it from the outside world, which is why if you're using something like, I'm not sure if it's dev random or dev urandom on Linux, but one of those can actually run out if you don't input anything to the computer. So if you have a program that uses, I think it's urandom, which is the one that can run out. If you're using urandom and you just leave it, it will eventually just stop. And you go to find out why does it stop, and you move the mouse, and then suddenly starts working again because you gave it random inputs. So that computers only reduce, and what I'm going to show you now is some statistics. And what I've done is I've taken data and I've reduced it. So what I've done is I've ruined the data in a productive way, because ruin isn't only negative. Okay, I like this quote. So let's look at some correlations. This is from 2016. I don't have the latest versions because I'm lazy. And this one proved my point, so I'm not going to do it again. Okay. Is there a correlation between your code quality and how well the project works? Answer, maybe, but not by much. Is there a correlation between how well your project works and how many lines of code you've written? Absolutely not. Is there a correlation between your code quality and the number of lines you've written? No, there isn't. The project doesn't need to be massive. If you're writing 2,000 lines of code or writing 800 lines of code, you can both get top score or bottom score. Right? So pay attention to what happens when you cross like the 1,000 or 1,000. This is including a driver, which is 250 lines of code. So when you cross the 1,000 lines of code mark, just pay attention that you're actually close to the end. And you don't just keep adding random stuff, because eventually it just grows to the point where it doesn't, you're not achieving more, you're just being less efficient than you could be. Then there's this thing that happens with, okay, let's just put it this way. There's nothing wrong with putting in effort. Right? There's nothing wrong with working hard. But the problem is that we can't stop you from working hard. And this was the 14th of April. 2 people handed in on the 14th of April around midday. And the deadline was midnight between 17th and 18th of April, as you can see. What's interesting here is that it looks like the rate at which people hand in increases exponentially as the deadline approaches. So what do you do when you see something like this? Well, you decide, what if we invert the axis, and instead of its time going forward, it's minutes remaining going, so it's time going backwards. And we plot that logarithmically, and then we have number of groups remaining, and then we see, do we get a straight line? Because if we do get a straight line, people are in fact handing in at an exponentially increasing rate as the deadline approaches. And the answer is, of course, yes. What did you expect? Of course it's a differential equation. Like, they're all over the place. It's first order differential equation. It's the most obvious thing in the world. But okay, let's look at something a bit more interesting. We're going to use the logarithmic plot for time, and we're now going to look at the completion score. Like, how well did the project work? Is there a correlation between how soon you delivered and how well it works? And the answer is, of course, yes. This is 1 minute before the deadline, so 4 people handed in 2 minutes before the deadline. Risky business, but at least it wasn't 1 minute. You got that going for you. Okay, so what this doesn't mean, but I'm going to say it anyway, is that if you hand in 16 times earlier than another group, you get 1 more point on the completion test. So compared to a group that hands in 1 minute before the deadline, if you hand in 15 minutes before the deadline, you get 1 more point on average. If you hand in 2 hours and 15 minutes before the deadline, you get another point. And if you hand in 3 days before the deadline, you get another point. In other words, if you hand in 3 days before the deadline, you get 3 more points on the completion. I mean, that's not exactly how it works, but the point is, if you put yourself in a position where you are able to hand in 3 days before the deadline, you're doing so well that you don't need the last 3 days. That makes sense. That makes too much sense. The other thing is, okay, you might expect there to be something similar for code quality. Like, if you rush it for code quality, does it get better or does it get worse? And the answer is yes. There's absolutely no change. In other words, if the only thing you're fixing in the last 2 days is your code quality, there's a chance you're going to make it just as much worse as you make it better. So it's not worth investing that time. Don't backload the time investment. I mean, everybody says this, like, get started now, work continuously, don't rush it at the end. But I have data that shows it's true. So now what's going to happen is you're not going to do as I say, and I can plot the exact same figure for you this year as I did in 2016. That's what's going to happen. And you're gonna rush miserably the last weekend trying to get everything together. That's what's gonna happen. And there's nothing we can't stop that from happening. And then you're gonna complain that the project is too large. And we're like, I told you so. And there's nothing we can do about it. We've reduced the project size enough times now. I mean, when I took it, there was no network module, there was no driver, and there was no simulator. You had to create everything yourself, and there was also the stop button and the obstruction, which we may add back this year, I'm not quite sure. And the project was too large, and then we removed some stuff, and the project was too large, and we removed some more stuff, and we added the simulator, and the project was too large. What happens isn't that the project is too large, the problem is that you don't work efficiently. So where's my soapbox? Okay. And then the final part, this one doesn't actually include the correlation, I'm just going to give it to you verbally. We had the design review. In 2016, the design review was actually at the end of the semester, not in the middle. And this was the kind of presentations I got. So about a quarter just did everything orally. They had no figures, no paper, no nothing, they just talked. About, let's just call that 2/3. I had some amount of figures on paper or something. You can also include the booklet part. They had, a booklet, they had figures and they had stapled them together. And then you had the people who had figures but they hadn't stapled them together, they had it on a computer. And those are also the final part. And then you had the whiteboard people who used the whiteboard. So basically figures, and then the 1/4 no figures. And the question is, how well did they do on the completion part? Well, the no figures part got an average score of 5.3, And the figures people got an average score of 6.6. Wow, completely unexpected. Well, it basically means if you create some amount of figures, if you visualize the problem in any capacity, you will do better. And here's the point I want to make. Don't start writing too much code too early. Make sure you completely understand the problem first. Make sure you know where you are and which direction you want to go in to move towards the horizon. And try to map out that path as much as you can before you start walking it. Okay? And make sure along that process that you ask the questions you need to ask to make sure you are not straying too far off the beaten path. Okay? I'll see you tomorrow.